Hello everyone, I am Aromaticity. Who are watching first time my video, subscribe my channel and share to your friends. Previously, we discussed the questions of 1 to 33 for CPGET 2021 question paper of chemistry. Now I am going to discussing about remaining questions. Next question number 34, right? Before that, please subscribe my channel and share to your friends. So question number 34, what is that? The given 10 ml of 0.02 m K2Cr2O7 solution is required to react with 12 ml of FeSO4 solution. The concentration of FeSO4 solution is. So the given, first I am writing the reaction. K2Cr2O7 is reacts with FeSO4 plus H2SO4. It gives to Cr2SO4 taken 3 times plus Fe2SO4 taken 3 times plus 7 moles of H2. Here if you balance the equation, you will get 7 here, you will get 6 here. So the K2Cr2O7 and FeSO4 ratio is 1:6. You can say it is 1:6. If I will write to find the K2Cr2O7 and FeSO4 molarity. So FeSO4 molarity we have to find. So K2Cr2O7. So general molarity formula is what? M1V1 by N1 is equal to M2V2 by N2. So this is the formula I am going to take. So M1 is given, right? What is the M1? So I am writing here. Molarity of K2Cr2O7. What is the molarity they given? 0.02 mole M, right? So then what is the V1 volume? What is the volume they given? 10 ml, right? So then N1 is 1 mole, right? 1:6 ratio should take 1. So for FeSO4, M2 we have to find because there is a question mark. So in the question they asked the concentration of FeSO4 solution. So then V2 is they given. What is the V2? 12 ml they given, right? Then what is the N2? N2 is 6 moles. 1:6 ratio 6 moles. So now substitute in the formula. What is the M1? M1 is 0.02 into what is the V1? 10 divided by 1. So what is the M2? M2 is what? For question mark, right? What is the V2? V2 is 12 ml by, so N2 is 6. 6 ones are 6 twos are cancel. 2 ones are 2 fives are cancel. So M2 is equal to 0.02 into 5. What you will get? 0.02 into, directly you should write 0.02 into 5. 5 twos are 10. So 5 here you will get 0.1. So directly you can say 0.1 m concentration of FeSO4 is present in the solution. So option number 4 is the correct. So out of this option number 4 is correct. This is about question number 34. Next question number 35. Next question number 35. Right. Major product formed in the following reaction. So they given question number 35. What is the question? So they given the neopentyl chloride. This is called neo. So generally if it is a tertiary butyl, so but means 4 carbons. If it is a tertiary carbon, tertiary butyl, so if you add along one more carbon, this is called neopentyl chloride. Neopentyl chloride upon reacts with acetic acid, this is formic acid, HC11OH in presence of water. So it gives generally. So how the reaction is we will see. Directly I am writing this chloride by the addition. So in formic acid they releases the H plus ion. So that gives it contains a HCl ion. HCl is removed. So you can get plus charge here. CH3 CH3 then CH2 plus, right? But this is a primary carbocation. To get the stability of this, the CH3 is migrating here. You can write the structure to get the stability. You will get CH3, CH2, then CH3. So here you will get plus, that is tertiary carbocation. This is the tertiary carbocation, this is the primary carbocation. So by the addition of water is there, H2O you will get. So you will get what? OH here. So that answer is CH3 CH3 OH here, CH2 CH3. So this is what our option. CH3 CH3 OH CH2 CH3, right? This option number 4 is correct. Next, question number 36, right? Question number 36. Next question. Question number 36. What is that? Which of the following is optically active? Question number 36. Which of the following is optically active, right? So mesotartaric acid, they given cis 1,2-dichlorocyclopropane, they given 1,3-pentadiene dichloromethane. So what is mean by optically active? Optically active means, so it should not contain the plane of symmetry. If contain the plane of symmetry, it is not optically active. So we will write the structures one by one, then we will understood which contains the plane of symmetry. So first, mesotartaric acid. I am writing the tartaric acid structure here. COOH, COOH. This is HOH, and here also HOH is there. This is mesotartaric acid. Mesotartaric acid. What is the second one? This is option A. What is second option? B. Cis 1,2-dichlorocyclopropane, right? So first cyclopropane you should take. Cis means same side. 1,2-dichloro. This is if I will take 1, 2, 3. So 1,2-dichloro. This is a chlorine, hydrogen. This is a chlorine, hydrogen. So the remaining here it is hydrogens only. So no need to write here. You can, if you want to write, you can write. So this is what? Chlorine. 1,2-dichlorocyclopropane. So what is third option? 1,3-pentadiene. 1,3-pentadiene. Penta means 5 carbons. You should take 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 carbons. 1,3-pentadiene. CH3, CH2. This is CH2, CH. This is what? CH, 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 CH3. Right. 1,3-pentadiene. What is the fourth option? Dichloromethane. This is the methane. Dichloro means only methane means 1 carbon. This is a 2. Dichloromethane means you will get hydrogens there. Right. Now if you observe this, so which of the following is optically active means, so we will write the plane of symmetry there. So this is the plane of symmetry, hence it is optically inactive. So here also plane of symmetry is present. If you pass the axis through like this, you will get a chlorine gets reflected and hydrogen reflected, and this is passed through hydrogen, hence this is also optically inactive. So here also if you pass this like this, so hence that means you can pass through like this. Cl gets reflected and you can pass through 2 hydrogens. So one is front side, one is back side, same like tetrahedral model. In tetrahedral C2 axis is there, right? Hence it is optically inactive. Only the structure contains optically active is 1,3-pentadiene, because there is no plane of symmetry. If you pass now, so then here double bond is there, here not double bond is not present. If you pass like this, it is okay, but here double bond is there, here double bond not present. Hence it is optically active. Compared to all, only option C is the correct one. Next, question number 37. Question number 37. In sucrose, glycosidic bond present between, right? So what is the glycosidic bond present between? Options they given C2 of glucose and C1 of fructose. C1 of glucose, like these options given. First I am writing the glucose and fructose structure. Generally answer is C1 of glucopyranose and C2 of fructofuranose. C2 of fructofuranose. If I will write directly, this is a sucrose, this is a what? they asked the sucrose glycosidic, right? So directly if I will write the structure like this, if I say that this is the pyranose structure of glucose, and if I say directly so this is the first carbon, this is the second carbon of fructose, this is the first carbon of glucose, hence it is called the glucopyranose and fructopyranose. You will not understood, but for this I am going to explain the little concepts for all sucrose and everything structure. You can know this. First I am writing the glucose structure, right? Glucose. What is the glucose structure? Here glucose is aldehyde group CHO, here CH2OH. These are the HOH, OHH, this is HOH, and again HOH. This is the glucose structure, right? So if you want to write glucopyranose structures, pyranose means C1, C5 carbon. This is the first carbon, 1, 2, 3, 4, 5. So if I want to write the pyranose structure, here aldehyde group C double bond H is there na, that H I am writing here, the double bond over here generally it is there. So but while you want to write pyranose structure, this is going to connect directly with this OH, so you can write O here and the remaining H here, OH. So whenever this is the C1 to C5, so if you consider 1, 2, 3, 4, 5 including oxygen, it is a 6-membered ring. So hence OH is present at right side. So hence it is alpha glucopyranose. Alpha glucopyranose. If you will take the OH at left side, that is beta glucopyranose structure. So the structure is similar to Haworth structure. Haworth structure is the cyclic structure you should take. So if I am writing here like this, you should write upper one is left side and lower one is right side. Upper one is left side is what? H. H I am writing here. Lower one is, you should write like this. This is H, OH is there now. You should write upper side H, lower side OH. Same here you should write OH. And second one, that is a H, that is a OH. This OH is here. Next, same similarly OH, third one H. Fourth one is HOH. HOH. Fifth one should be HCH2OH, but this gets interchanged. You should write the CH2OH H here. This is the structures of Haworth, HAWORTH, Haworth structure. So if I write the structure in the form of cyclic model, chain model, you can say this is what? Cyclic model. This is axial equatorial. This is what? Axial equatorial. Here also you will get axial equatorial, axial equatorial. Here also same axial. This is equatorial, this is the axial structure. So for this, H is like this here, equatorial, OH is axial. Similarly, H is axial. I am not writing only hydrogens, I am writing only OHs. So downside, this OH is upside. Next, H is up, OH is down. Then this is CH2OH. This is alpha glucopyranose structure. Alpha glucopyranose structure. So this structure you should keep in mind. So that structure I am going to use while writing the sucrose structure. So next I am going to take the fructose. What is the fructose? This is what fructose. C double bond O, CH2OH. Same like glucose. The remaining last three are the glucose only. OHH, HOH. This is also HOH. Then remaining is CH2OH. If I will take here like this. So if you will write directly Haworth structure, for this if you want to write same like furanose structure. Furanose means 1, 2, 3, 4. C1 to C4. Only 4 membered plus including oxygen it is a 5 membered ring. So that CH2OH I am writing here. CH2OH, and while you are writing double bond O means you should write OH here. Now you should write this OH is here. So now you should write the structure of furanose. This is what furanose. I am writing here for our convenience. So here, now same like we should follow from here. CH2OH is top side, then OH is down side. Similarly, if you will take second one, OH, H. This is first carbon I am taking. This is the first carbon, this is second carbon. So next, third one is H, OH. Next one is CH2OH, and down side is H. This is about beta fructose. So actually, so we need the beta, right? Beta fructose, but it is alpha. If you want to write beta, just interchange OH. You should write the left side. OH, CH2OH. You will get same. Similarly, here also you will get OH upside and CH2OH downside. Same like nothing is there. OH is left side present. Hence it is beta. Beta fructose furanose structure. So same similarly, if you will take 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 carbons you will get. So now I am going to use this structure. Use this structure. So first I am going to take the glucose, right? What is the glucose structure? I am writing only hydroxyl groups, OH. So this is what? OH here, OH here. This is OH, and remaining here CH2OH. But while I am taking this, so for our convenience, just you should write. You can also write like this. If you want to write here directly, you should write the structure of fructofuranose here. I am just interchanging this. This is like flipping. Flipping means this OH comes here, then CH2OH comes here. Next attached carbon is what? This one. This OH comes here, and remaining H comes here. Then next third one H, OH. Then fourth one CH2OH and H. So if you will OH, it will remove the water H2O. So you will get bond like this O. So this is called C1 of glucose, and this is one carbon. This is two carbon. C1 of glucose and C2 of fructose. C1 of glucose and C2 of fructose is called the sucrose bond. Is called the sucrose. Hence option number 3 is correct. This is the basic important concept. Because of this reason only I am explaining in deeply for further concepts. Same like for sucrose and maltose, lactose and everything, you should know this concept. In this C1 of carbon we took now, so that there is no free hydroxyl group, hence it is a non-reducing sugar. That already we discussed. Question number 38. What is that? Which of the following molecule can produce the isotopic peaks of M and M+2 in mass spectrum with almost equal abundance? Almost equal abundance means, so for example, M peak and M+2 peak, right? M peak and M+2 peak. So for bromine 79 and bromine 81. So that is 79 plus 2 is 81. So that is 100%. 79 bromine is 100% is there. If 81 bromine should be almost, it is 98 or 99% something, 98%. So it is almost equal to 100. Hence we can say whenever isotopes of bromine is present, that should be in the ratio of 1:1. So if I will take similarly M and M+2, so if M should be is 100% in the chlorine, if I will take chlorine 35 and M+2 is 37 chlorine if I will take, so that is almost equal to 31 or 33% if I will take 33%, if you will take 33% abundance. So it is almost 100:33 means you will get 3:1 ratio. So that time we can say the chlorine should be present. But 1:1 is almost equal abundance. Equal abundance means bromine should be there. So which of the following option contains the bromine? So bromine contains only first option. So hence it is the bromobenzene. So option A is correct. Option A is correct. Next question number 39. What is that? Which of the following can produce the methane on hydrolysis, right? So option calcium carbide, beryllium carbide, aluminium carbide they given, but I am writing the reaction of all calcium carbide and next is beryllium carbide, then aluminium carbide they given Al4C3. All reacts with water, right? Upon hydrolysis, very important reactions for any competitive exam, right? For calcium carbide, it forms the calcium hydroxide and acetylene C2H2, or you can say HC triple bond CH. So acetylene gas released. So hence we can say we have to take 2 moles here. So this is what C2H2. For beryllium carbide water, you will get 2 beryllium hydroxide plus CH4. You will get CH4, methane. So already this is the correct option, methane. We will check for this Al4C3. You will get here 4 moles. You will write. So here if you will write 8 moles, so you will get 4 AlOH taken 3 times. Then you will get 3CH4. 3CH4. This is also methane is there. So option beryllium carbide and Al4C3. So the option should be C and D. That is, otherwise you can say 3 and 4 are correct because calcium carbide release the acetylene, hence it is the wrong option. Except this, so 3 and 4 are correct, but the options they given A and B. So that is the wrong option. You will get the marks there that time. So this is the methane gas released in the Al4C3 and beryllium carbide. Next question number 40. This is the theory oriented question, that is from the surface chemistry. Surface tension of liquid becomes 0 at. Already we know that what is the point? It is 0. It is a critical point. Option 3 is the correct. So I am not talking about the remaining options because directly we can say. So the decreasing order of the chemical shift values in question number 41. Next question number 41. Very important. They asked the basic concept from the NMR, from the chemical shift values. So you can see, in compared to like they given aldehyde protons, right? I am writing this is the aldehyde proton is greater than, option I am writing, then I will say the values for you. Then this is the aldehyde aromatic proton, aldehyde proton. Then what next? Olefinic proton. If it is a olefin, for example, olefinic proton. Then what is the next? Acetylene proton. Acetylene proton, right? So in NMR, the chemical shift values of aldehyde is very high, that is around 9.5 del value. 9.5 del value. The chemical shift values varies 0 to 20 hertz. 0 to 20 hertz. So this is the value is 9.5 del. So aromatic is almost 6 to 8 del, you can say. It is roughly in between 6.5 del. So these are around 4 to 6 del. So you can say 4 del. So it is around 2.5 del. So by seeing only one option in all these examples they given, aldehyde protons are the higher chemical shift. Only one option is there, that is option number 3. So you should just by heart the values of the chemical shifts. Then you will understood the concept of NMR. This is about question number 41. Option 3 is correct there. Next, question number 42. Basic concept from the symmetry. What is the point group of NH3? Right? NH3 point group, NH3 structure you should know first before going into this. NH3 means it is a pyramidal structure with one lone pair, right? Pyramidal structure with one lone pair. It contains the C3 axis and 3 C2s are there and 3 sigma V's are there. It is a C3V point group. C3V point group. Directly we can say basic concept. Options they given C3V. For D2H, best example is D2H is what? Ethylene. Ethylene means CH2 double bond CH2. The structure is like this, H, C, double bond C, H. This is the ethylene structure. That is the best example for D2H point group. And C2V point group, water you can say H2O, water. And tetrahedral, just basic examples I am discussing about the for options. For tetrahedral you can say methane, CCl4 etc. you can take. Next, question number 43. What is the question number 43. The BHB bond in diborane. Very well, already we know that. What is the BHB means? In diborane, diborane means B2H6, right? B2H6. What is the structure? This is the structure of diborane. This is the structure of diborane, right? Diborane is a three-centered. This is a three-centered and two electron bonds. You can say this is a one BHB bond is present. This is another BHB bond. So this is called banana bond or tau bond. We can say banana bond or tau bond. This is a example of three-center and two electron bond. Three-centered, two electron bond. Basic concept they given. You should study the remaining examples related to BHB. Now question number 44. Question number 44. What is that? Which of the following has a highly reactive in hydrolysis reaction? Hydrolysis reaction means, if you observe the example 1, option 1, if you will remove the chloride, you will get a plus here. If I will write this one, that is what second option, bromine, you will get the plus here. If you will write, this is what cyclopentadienyl bromide. If you will remove this, you will get the plus here. So this is what tropylium cation. So tropylium cation is aromatic and it is stable. It is mostly involved in the hydrolysis reaction. You can write like this. So because it is a aromatic, once it forms, it's a aromatic reaction. Next option 4 is correct. Next question number 45. What is the question number 45? Among the following relatively more acidic compound, right? Before that, just you remember, acids are more acidity of acids are more than it is acidity of acids are more when compared to phenols, or you can say alcohols. Like, so acidity of COOH is greater than like phenols or something alcohols. You can say alcohols. So in the example they given, so phenol is directly you can eliminate from the option. So remaining options I am writing acetic acid, CH3 C double bond OH. This is what acetic acid. What is the second example? Chloroacetic acid. Chloroacetic acid means this is a chlorine group, this is the acetic acid. And what is the third one? Trifluoroacetic acid. This is a fluorine, this is a fluorine, this is a fluorine, this is a C double bond OH. What is mean by acidity? First, acidity means which releases H plus ions very easily. So if you break this bond, what happens? If you want to break this bond, so something should be withdraws from this electron deficient carbon along with this group. So hence it should be, there should be minus I group, but here plus I group, actually whenever it gets, it should be releases H plus ions, you will get the minus ion. So but minus ion is not stabilized by O. So hence that means it should be CH3, but whenever you have the CH3, it is donating to this, you will get O minus, so hence it is not stable. So hence you can say simply whenever minus I groups are there, plus I groups are there, it is not that much acidic. Whenever chlorine is there, so this chlorine is withdraws electron density from this group and easily releases H plus ions. Whenever fluorine is there, so whenever fluorine is more electronegative than chlorine, so here 3 fluorines are there, the 3 fluorines are strongly withdraws electron density from this bond, so then now easily H plus ions is removed, easily H plus ions is released, hence that is more acidic. If they will give order also, you can write this order is the correct for acidity of this 3 comparison. So now option C is the correct for the acidity order. Next question number 46. 46, right? Identify the relative reactivities of the pyrrole and furan, thiophene and benzene towards electrophilic substitution. So for this, I will discuss some concept first. First, aromaticity or resonance energy of, previous question I am writing, mostly they asked in many times. Benzene is more aromatic than thiophene. Thiophene, right? Thiophene, then pyridine, then pyrrole, then furan. In case if I will consider the resonance energy 36 kilocalories, here thiophene is around 30 kilocalories, here pyrrole is 28 kilocalories, here this is 22 and this is a 16 kilocalories. This is the aromaticity order. If they will ask in the examination, we can expect this type of questions. And also the resonance energy or aromaticity follows the same order, right? So if they will ask the electrophilic substitution order, so generally electrophilic substitution, pyrrole is what? Nitrogen containing aromatic heterocyclic compound, right? So this is what? Pyrrole. Pyrrole is, furan is greater than thiophene. So pyrrole, furan, then thiophene, last one is benzene. This is the electrophilic substitution towards the pyrrole, furan, thiophene. If you will say dipole moment order also same. Nitrogen containing is pyrrole, then furan, then thiophene. Both follow the same order for this dipole moment. This is about aromaticity concept. Electrophilic substitution towards is pyrrole, furan, thiophene, then benzene. Option number C is correct. Next, question number 47. In a first order reaction, 10 moles of reactant converted to 5 moles in the period of 1.5 hours. After what time the reactant becomes 0.01 moles? So generally 10 moles of reactant converted to 5 moles, right? 10 moles converted into 5 moles in the period of 1.5 hours. In the period of 1.5 hours. So after what time the reactant becomes 0.01 mole? 0.01 mole. So generally we know that T 99.9% is equal 10 T halves. 10 T halves, right? T 99.9% means directly you can say here this is a percentage of reaction completed, the remaining reaction is 0.1. Generally we can say 0.1. So now if you like 10 to 5, then 5 to 2.5, so if you will further follow this, you will get 1.5 hours into 10 times, you can say, so 10 times, so that is you will get 15 hours. Option 4 is correct. Option 4 is correct. Next, question number 48. What is that? Reaction of AlF3 with an excess of F minus gives, right? So AlF3 with, generally AlF3 reacts with excess of F minus means generally HF does not react with AlF3 because HF is a covalent bond, hence it does not releases H, the bond is very strong, hence it does not releases F minus ions. So AlF3 reacts with NaF, sodium fluoride, right? Very easily because it is a ionic bond. So with 3 moles, it is a 3 moles. You will get the Na3AlF6. So if you break this, you will get 3 Na plus ions plus AlF6 minus 3. So AlF3 with reacts of excess of F minus, you will get what? AlF6 minus 3. So option number 4 is correct. This is about 48 question. Next, question number 49. This is a theory oriented question. Which one of the following is related to metallic bond? So that is related to Pauli's exclusion theory. So that is fourth option. Next, question number 50. Among the following, the more basic compound is what? Generally you should remember aliphatic amines are more basic than the aromatic. Aliphatic, you should keep it in the mind. aliphatic amines are more basic than the aromatic amines. Aromatic amines, very very important. So first I will write the structure. So acetamide, right? CH3 COO NH2, acetamide. Then second one is a methylamine, CH3 NH2, Third one aniline, NH2 aniline. Fourth one NN-DMF, NN dimethylamine, NN dimethylamine, NN dimethylaniline, right? So first, this is what CH3 COO NH2. So next methylamine. So now we can simply eliminate the aromatic amines are less basic than the aliphatic. So because this lone pair is involved in the lone pair is, what is meant by basicity first? What is meant by basicity? Donation of electrons very easily. Donation of lone pair of electrons very easily is called the basic nature. But in this aromatic, the lone pairs is involved in the resonance, hence it is not available. So donation is very hard to donate. So hence this also contains the even CH3 So this lone pair is involved in the ring resonance. So hence those are not available. So now if you compare this one and this one, so CH3 is the plus I group. CH3 is a plus I group. CH3 COO is a minus I group. This is a withdraws electron density from the nitrogen, means this lone pair is from this towards this side. Hence the lone difficult donation of lone pair is difficult. So hence this is the plus I group. It is releases the, it means it gives the electron density to nitrogen. It is easily gives the lone pair. Hence methylamine is more basic than the remaining. Methylamine is more basic than the remaining things. Next 51, right? Which one of the following is an anti-aromatic compound? So anti-aromatic rule is what? 4N. Which follows the 4N is anti-aromatic. Which follows the 4N plus 2 rule? That is Huckel rule. That is called aromatic. So here N means you can take N is equal to 1, 2, 3, 0, 1, 2, 3, 4, so on. So N is equal to 1 if I will take. So you will get 4, 8, then 4 3 is 12, 4 4 is 16. These number of 5 electrons should be present. First condition to satisfy the aromatic or anti-aromatic, it should be follows the Huckel's rule, and both should follow the sp2 planar geometry. sp2 means planar geometry. So if contains the sp3 hybridization, it is not aromatic. It is not aromatic condition. So now if I will observe the options, option 1, that is what? Cyclopentadienyl anion. So this is what? Cyclopentadienyl anion. This is 2 electrons, minus means 2 electrons. Total 6 pi electrons are there. Hence it is aromatic, not anti-aromatic. So this is aromatic. So but our option they asked anti-aromatic. Second one, there should be resonance. Resonance should be also there. Here continuity is not missing. Here also resonance is there, and all are planar structure. And if you will take this is what? 2 pi electrons. This is also aromatic. And what is the third one? Third one is not aromatic because this contains the sp3 carbon. Because here hydrogen is there, here hydrogen is there. What is meant by hybridization? Number of bond pairs plus number of lone pairs. Number of how many bond pairs? 1, 2, 3, 4. 4 bond pairs means sp3. Hence it is not aromatic. So the remaining option, cyclopentadienyl cation, fourth one. So that is 4 pi electrons, continuity is not missing. 4 pi electrons means you can say this one. So that is follows the anti-aromatic condition. Option 4 is correct option. Next question number 52. Examples of N-type semiconductor is Example of N-type semiconductor. So generally there are two types of semiconductors. What are that? Intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor means purest form of the semiconductor is called the intrinsic semiconductor. What is meant by extrinsic semiconductor? Extrinsic semiconductor. The semiconductor in which it is doped with the higher or lower group elements is called the extrinsic semiconductors. Again, these are classified into two types. One is N-type semiconductor, one is P-type semiconductor. So N-type semiconductor means, this should be doped with the higher group elements. P-type semiconductor means this should be doped with the lower group elements. Examples, higher group means, example I am going to take 50A group. Lower group means 30A group. Now I will explain how to remember all this. So you should just follow the N-type and P-type. So first, you know the fourth group, right? You should take generally 3rd A, 4th A, 5th A. What is the fourth group? Carbon, silicon, germanium, tin, lead. So this acts as, except carbon, some acts as silicon, germanium, tin. These are acts as semiconductors. So here I am going to take boron, aluminium, gallium, indium, thallium. Next, third group is what you can say? Here nitrogen, phosphorus, arsenic, antimony, bismuth. So boron is what? Third group is boron, aluminium, gallium, indium, thallium. These are the third group. So now if I am going to take silicon as the semiconductor, you can take germanium as the semiconductor. So this silicon is doped with the, let's say I am taking in this third A gallium. So silicon is doped with the gallium, is called the which conductor? Lower group elements. This is a lower group elements. You can say it is a P-type semiconductor. So if you dope with the higher group elements like arsenic, so I will write here N-type. For your clarification I am writing N-type. So for example, arsenic is there. Arsenic contains what? How many electrons? 5 electrons, right? Valence electrons, 5 electrons is there. 1, 2, 3, 4. 1 is extra electron. So for gallium, if I will take, how many valence electrons? How many? 3. 1, 2, 3. 1 is the whole. So if I will take silicon, right? Silicon is what? To form the bond, silicon should be donated the 1 electron. Silicon carbon valence is 4, right? 4 means like you can say so if you observe this, so this contains the one hole. Silicon donates the 4 to form the bond, but this contains a hole. This is a P-type. Holes are P-type. If you compare this, same silicon is there. If you will write, how you will write same silicon? Here same silicon. Silicon contains 4. But here same silicon contains 4. Here also same, but one vacant space is created, that is hole. One extra electron is present, that is N-type semiconductor. So you just remember like this, you never forget this concept. So answer is boron doped with silicon, that is not N-type. Boron doped with silicon is what? P-type. First option is wrong. Gallium doped with germanium. Again it is a P-type. Indium doped with germanium. Again it is a P-type semiconductor. Now what is the fourth option? Phosphorus is doped with the silicon. So that is a N-type semiconductor. This way you can do any example from the N-type, P-type. You just use this method. You will get the clear answer. No confusion. Next question number 53. What is that? Which of the following reaction is stereospecific, right? So hydrolysis of 2-bromobutane. So generally 2-bromobutane is 2-bromobutane. Butane means what? 1, 2, 3, 4, right? 1, 2, 3, 4. 2-bromo means second place should be, bromine should be there, and this is one CH2, CH3. So this is what? Hydrogen. So we can say CH3, hydrogen, bromine, and CH2, CH3. So these are the 4 groups. You can say like, if it is I am writing, this is what? Bromine is here. For example, if I am writing here, this is hydrogen I am writing here. This is CH3 I am writing here. This is C2H5 I am writing here. So generally, if you will consider this, first number of highest group is first, second, third priority, fourth priority. 1, 2, 3, 4. That is clockwise. Clockwise means R. R becomes S, because R becomes means what? S. So because this hydrogen is in fourth group is in the thick line, hence it is S. R becomes S. S2-bromobutane. It is S2-bromobutane. But they didn't give the whether it is S or R. So what is meant by stereospecific? So we will get the S2-bromobutane we will get, and R2-bromobutane we will get. So what is meant by stereospecific means, if you will take the cis compound, you will get the cis product, cis reactant, cis product, trans reactant, trans product. Similarly, out of all this, we will get only one possibility there for the hydrolysis of 2-bromobutane, that is a stereospecific reaction. Next, question number 54, that is option 1 is correct. Next, the product obtained on reduction of propane nitrile with dibal H at low temperature. So what is meant by dibal H? First you should know the dibal H, right? Dibal means diisobutyl. This is the isobutyl. 1, 2, 3, 4 carbons are there, diisobutyl. So this is again 1, 2, 3, 4. Isobutyl, isobutyl, diisobutyl. Here I am writing aluminium. For this diisobutyl, Al means aluminium, and this is H. Diisobutyl aluminum hydride. So this is called dibal H. Dibal H. So I will write the reaction. So directly I will write the reaction with mechanism. Propane nitrile. Propane nitrile means CH3, 3 carbons, CH2, fourth carbon is nitrile, nitrile group, CH3, CH2, Cn. This is a propane nitrile. We can say Cn is like this, C triple bond N. So that is react with dibal H in presence of what? Low temperature, minus 78 degrees. Generally it is minus 78 degrees. And further on hydrolysis in the presence of water. So what happens? The reaction is, so you can say dibal H is already, we know that what is that? Aluminium. This is the structure of dibal H. This is hydrogen. So whenever it is there, aluminium contains some vacant orbital, the nitrogen contains a lone pair that is going to donate to the vacant aluminium, and it forms the CH3, CH2, and you will get C triple bond N. So this is what? Aluminium. So you will get here one isopropyl group, here one isopropyl group, and hydrogen is here. You will get nitrogen plus, aluminium gets negative charge. So after this hydrogen is donated to this carbon, and this bond gets migrated, and this group gets, we can remove like this. After this you will get CH3, CH2, C, H, double bond N, and Al. This you will get like this, you can write. So after this, if you will do the hydrolysis, you will get here O. So hence you can write, upon hydrolysis H2O, you will get CH3, CH2, C. See here double bond O is there na, double bond O H. This is what? 1, 2, 3. 3 carbons means propane. Al means is there, you can write propanol. Al means aldehyde group. If OL means alcohol group, that you should clear. Propanol. This is about 54. What is the option? Option number 4 is the correct. Next, question number 55. This is from the gas state Direct answer, which of the following gases cannot be liquefied easily? So that is related to, so that is what A and B values, it depends upon the A values, B values. The answer is hydrogen and helium. You go through the theory. And question number 56. What is that? The number of stereoisomers possible for cobalt NH3 taken 2 times Cl2 Br2 charge minus. So generally here cobalt NH3 means you can say it is A2B2C2 type. Cobalt A2B2C2 type. Cobalt you can say simply it is metal Ma2B2C2 type. Generally it exists as 6 isomers. I will give the all 6 isomers because we don't have much time to detail all. So just I will give the slide for this. Next 57. What is that? In a chemical reaction, the half-life is 50 minutes when the concentration is 10 minutes. The half-life is 25 minutes when the same reaction starts with the 20m, the order of the reaction, right? So if 20m is there, so if it starts with 20m is converted into 10m generally, so the half-life given it is 50 minutes when the concentration is 10 minutes, so the half-life is 25 minutes, the order of the reaction. Order of the reaction, if you will substitute the order of the reaction, you will get second order. You will get the second order. Order is second. If you will use the formula of second order like Kn is equal to, generally what is a Kn is equal to, for nth order I am writing 1 by T into 1 by A minus x all to the power of n minus 1 by A to the power of n. Kn is equal to, you should write, here gets cancelled, if it is second answer you can write here n minus 1. If it is second order you can keep the, in place of n you should keep the 2 just, you will get, so here what, 1 by T into 1 by A minus x you will write. Power n minus 1 is what? 2 minus 1. Otherwise you can say the reactant concentration is inversely, half-life is T half is directly inversely proportional to 1 by K is called the second order reaction. So directly from this you can say it is a second order reaction. So you can directly write, next if you want to write 2 minus 1 is 1 and 1 minus A power 1 by A. So if you do this, Kn is equal to 1 by T into, so do the cross multiply, A minus of A minus x divided by A into A minus x. Here A minus A get cancelled, you will get minus into minus plus x, you will get x by T into A minus x. So if you will write half-life, you will get the Kd is equal to 1 by, half-life is inversely proportional generally. You know that T half is equal to what? 1 by A to the power of n minus 1, initial concentration. Half-life is inversely proportional to the initial concentration. So next question number 58, basic question they asked in the examination, the general formula for lanthanide oxides. So lanthanum generally it is in the form of lanthanum plus 3, oxides in the form of O minus 2. By crisscross method, if you will apply this, you will get, so here it is lanthanum, it's not lanthanum, it is lanthanide, Ln plus 3 O minus 2. So you will get LNO, right? But here you will get 2 here, 3 here, cross multiply, Ln to O3 is the concept. Ln to O3. Similarly, best example, for example, Mg, not MgSO4. For example, like Al plus 3, OH minus is there now. So minus 1 comes here, Al goes here, like Al, OH taken 3 times. Similarly, Ln to O3. This is question number 58. Next, question number 59. 59, this is from the colloidal state unit. So what is that? Which of the following statement is correct? Obviously, smaller the gold number, higher the protecting power of a colloid. This already we know that. You can read some important questions from the colloidal state, you will get the answer. Next, question number 60. What is that? The compound X on treatment with the hydroxylamine followed by H2SO4 forms acetanilide. What is the answer? This is the X upon NH2OH hydroxylamine. It gives what? Followed by hydroxylamine followed by H2SO4. Again, you will get something. Upon it is followed by H2SO4, you will get the acetanilide. What is the acetanilide structure? C double bond O NH CH3. This is the acetanilide structure. NH C double bond O NH3. Sorry. NH C double bond O CH3. This is the acetanilide structure. So first option they given acetamide, but I am not going to take the acetamide. Directly I am going to take the acetophenone as the X. How I will show the with mechanism. Acetophenone means this is the acetophenone. This is what? Acetophenone. Acetophenone upon reacts with NH2OH, you will get here NH2OH means like this N and H2OH. This O and H2 will remove. This double bond N attached here. Double bond N OH you will get. Double bond N OH you will get. Double bond N OH. So upon H2SO4, what happens is, upon H2SO4 there exists a lone pair. It is a Wagner-Mervin rearrangement. It is a Wagner-Mervin rearrangement. This is moves here. You will get C CH3 double bond N. This is pH and this is what? NOH, right? NOH. So if you will write, so furtherly, so what happens upon H2SO4 you will get the Beckmann concept. This is what? Beckmann concept. CH3 N double bond O CH3, right? Now if you will write pH, here same like pH is there, N is there, then you will take here, generally what happens is here something here like OH minus. If you will take OH minus is going to attack here. So upon what they asked, H2SO4, right? Upon H2SO4 you will get the concept. So from NH2OH you will get the OH minus, you will get O minus and H here. So once it gets removed, you will get O double bond O here. So the same like pH NH C double bond O CH3 you will get. So pH NH C double bond O CH3. This is a mechanism I am not going to write completely. So pH NH C double bond O CH3. So this is about acetophenone. Next question number 61. What is the void space in simple cube? What is the void space in simple cube lattice in percentage? So generally in solid state already we discussed solid state unit, solid state part 1 and part 2. So the solid state simple cube, BCC and FCC we discussed, right? So simple cube, so that is a percentage is 52%. So for BCC 68%, it is occupied packing fraction, you can say packing fraction 52%, 68% and 74%. So this is a packing fraction means, so 100 minus 52 is what? 48% is the empty space or void space. 100 minus 52. This is also same, 100 minus 52. So 48% nearer option is 47.6 option is there. So that is a simple cube. So void space. Option 1, option 3 is correct. Next question number 62. This is also from the solid state. Radii of cesium plus and Cl minus ions are 0.169 and 0.181 nanometers. The coordination number of cesium plus is ion in the cesium chloride. So generally R plus by R minus, the value is 0.732 to 0.1. So we can 0.732 to 1. So we are saying that it is a BCC structure. For BCC structure, best example is cesium chloride. So the coordination number of cesium chloride is 8. The coordination of cesium chloride is 8. This is a basic, already we know that. Next question number 63. In permanganometry titrations, which one of the following should not be used as medium? Should not be used as medium. So that is what? Question number 63. Which is not medium means HCl is not used in the medium. This is from the analytical topic. Next question number 64. What is that? Radiation of 1000 angstroms passed through 10 ml of 2m oxalic acid after absorption of 0.02 moles of photons. The concentration of oxalic acid reduced to 1m. The quantum yield of the reaction. Question number 64, right? What is the quantum yield formula? Number of molecules reacted in a given time. Number of molecules reacted in a given time by number of photons absorbed. Or you can say quantum yield one more is number of moles of reactant reacted in a given time. Reactant reacted in a given time by number of Einsteins absorbed. Number of Einsteins absorbed. So if you want number of molecules n is equal to, so number of molecules if you want, so you can say multiply with number of moles into Avogadro number. If you will use this formula and you will get the quantum yield is around 0.5. Next, question number 65. This is very important from the colloidal, that is what colligative properties. Which one of the following solution has the same osmotic pressure with 6% glucose solution? So generally for pi, osmotic pressure is equal to I into CmSt. This is a formula we are going to use, and we can also use pi is equal to W by V percent into 10 divided by molar mass, that is mb. So we are going to use any one of the formula, but here I am going to use this second one formula. W by V percent into 10 by mb is equal to, mb means you can say it is urea. For example, first the question is for 6% glucose, right? Glucose. Same here you can say W by V percent into 10 divided by, here mb is what? mb means urea, right? mb means what? Glucose molecular weight is 180. Here mb means urea molecular weight is 60. They given the 6% glucose. 6% glucose here, the value is 6. So 10 cancel here. So then 6 1s are 6 3s are 1 by 30. Here 0 is there, 0 is there. 3 1s are 3 2s are. So now you can write W by V percent of, cross multiply, W by V percent of urea is equal to, if 2 goes here, 2% of glucose. 2% of glucose. What is it? Here, just wait, done reverse. Sorry. Here, if this goes this side, what happens? 1 by 30, right? So 1 by 30. So if you will get 2%, here 2 cross multiply, what you will get? So here, don't write again glucose and urea. So direct write 2 is equal to W by V percent of, what is this? Percent of urea. 2 means what? We can say if it is in percentage, 2% of urea. So you can say simply which one of the following solution has the same osmotic pressure with 6% of glucose is 2% of urea solution. Option 1 is the correct. Next, question number 66, last one. In which of the following diastereomers, which one of the following reaction diastereomers are formed? Glyceraldehyde, CHO, CH2OH and HOH. Glyceraldehyde upon reacts with HCN, so you can say it is aldehyde means C double bond OH, upon you will get CN minus here, upon hydrolysis you can get the acid group, but here different OH groups are there. You can write here like HOH is there, you will get the 2 types diastereomers are present, because this is not changed only. Here you can write both the terms, so you will get the diastereomers formed in the glyceraldehyde HCN reaction. This is about question number 66. In next video I will discuss the remaining questions up to 100, so then we can finish our unit. So if you like my video, subscribe my channel and share to your friends. Thank you so much.